Welcome to the Foundry by Forge College. So today we're tackling one of the most exciting and, let's be totally honest, sweat-inducing transitions in Web3 development, the foundations of collaborative Solana projects. Now picture this. You've built a brilliant Solana project solo. It runs flawlessly, you bring on a team, and suddenly, utter chaos. Beautiful code just turns into this fiery tangle of merge conflicts. Well, today's explainer is basically your fire extinguisher and your engineering blueprint for scaling safely.
Let's compare the solo developer to team chaos. Think back to our previous lesson on Git integrated workflows. We got your local environment absolutely pristine, right? You had reproducible local workflows, your Solana CLI and Anchor steps were perfectly aligned. But then, think about team chaos. This is the absolute terror of a team pushing code simultaneously without any governance. I mean, if everyone's using slightly different toolchain versions or saving files in weird folders, you get broken builds and schema mismatches. It's a complete nightmare. Our goal today? Take that clean, reproducible solo workflow and actually scale it up.
Okay, here's the blueprint for today's explainer. 1. From solo to squad. 2. The CI workflow blueprint. 3. Defining team roles. 4. Setting up guardrails. 5. Step-by-step coordination. And 6. Keeping it reproducible. These are the 6 crucial steps to build a governable, automated factory floor for your Solana repository. Let's dive in.
Section 1. From solo to squad.
The crucial point here is this. Scaling requires structured collaboration practices, not just more developers. You really can't just throw 5 new devs into a repo and expect a 5x increase in output. Without governance, you're probably just getting a 5x increase in headaches. We have to transform our solo automation, those local scripts and checks you ran by yourself, into actual team-facing structures. We're essentially building the factory floor where everyone knows exactly how the assembly line works.
Moving on to Section 2, the CI workflow blueprint.
So let's break down this continuous integration, or CI, pipeline step by step. This is the automated machinery that ensures every single pull request goes through the exact same checks before it ever gets merged. First, we check out the code and cache our Rust dependencies to speed things up. Second, and honestly, this is absolutely vital, we install the toolchain. We're talking about installing the exact Solana and Anchor CLI versions. This guarantees everyone, and the automated system itself, is building with identical tools. No more "well, it works on my machine" excuses, right? Then we verify the layout, run our tests, and finally upload the artifacts like our test logs.
I want to double-click on Step 3 for a second. Repository layout verification is essentially a CI script enforcing exactly where a program's clients and tests must live. Think of it like a strict traffic cop. If someone gets sloppy and decides to drop a TypeScript client script right smack in the middle of the Anchor program's folder, the automated factory alarm will sound. The build will literally just fail, and that's a good thing. It keeps your repository clean and predictable as your team grows.
All right, Section 3, defining team roles.
Let's look at a typical 4-person core team scenario to make this a bit more concrete. First, we have Alice, our program owner. She owns the Anchor programs, ensuring on-chain interface stability and approving any changes to program IDs. Then we have Ben, the client integrator. Ben's job is to ensure the TypeScript client perfectly matches Alice's Anchor IDL updates. Chloe is our CI lead. She's keeping those GitHub Actions workflows and caching strategies running smoothly. And finally, Diego, the release manager, who handles the release tags and coordinates the merge windows.
And here's why defining those roles matters so much. Clear role interactions prevent ambiguous review boundaries and stalled merges. In our Forge College learning programs, we constantly see teams stumble simply because no one knows who's actually supposed to approve what. By mapping out these specific interactions, like knowing for sure that Alice must talk to Ben whenever an account layout changes, we completely prevent that dreaded schema drift between your on-chain programs and your off-chain clients.
Section 4, setting up guardrails. Think of your branch protection as a strict engineering spec sheet for safety protocols. We absolutely cannot have catastrophic factory accidents on our main code branches. Take the main branch. This is your production-ready code. It is heavily guarded. It requires pull request reviews, a passing CI build, and signed commits. You do not mess with main. Below that, develop acts as our integration ground, requiring a CI pass to ensure things actually fit together. And finally, our feature branches. These are your individual sandboxes. There's no heavy protection here, but you absolutely must go through a PR to merge them upward.
To enforce all of this, we use something pretty brilliant called CODEOWNERS. It's a metadata file that automatically requests PR reviews based on the repository paths that get touched by a code change. So remember our program owner, Alice. If someone makes a change to anything inside the programs folder, the CODEOWNERS file automatically pages Alice for a review. She becomes the automated gatekeeper for her domain. It completely takes the guesswork out of the review process.
Section 5. Step-by-step coordination.
Okay, let's track a single code change from a local laptop all the way to a safely governed merge. First, you run a local verify to ensure your toolchain is correct. Second, you cut a feature branch. Third, you run the test matrix, catching any schema mismatches locally before anyone else even sees them. Fourth, you open a pull request using a PR template, which automatically pulls in the handoff checklist. Fifth, you address any CI failures or reviewer feedback. And finally, step 6, a governed merge signed off by the right owners. It's a highly predictable, stress-free sequence.
Which brings us to a crucial question you might be asking yourself right now. Why go through all this trouble? Why map human roles to automated gatekeepers? Well, the answer is trust. It builds the fundamental trust that when a CI build passes, that code is actually reproducible and safe across everyone's machines. It means Alice trusts Ben's client code, and Ben trusts Alice's program updates, all because the automated gatekeepers verified the handoff.
And finally, Section 6, keeping it reproducible. To recap, if you want a successful, governed, multi-contributor Solana project, you really need these 3 main operational principles. First, pin your toolchain versions in CI so everyone is playing exactly the same game. Second, map human code ownership directly to repository paths using CODEOWNERS. And third, tie your branch protection rules directly to your governance decisions. This seamlessly connects your local toolchain automation with your team-wide human processes.
I want to end on this core principle. Treat reproducibility as policy rather than a suggestion. When your workflows are predictable, your team can focus on building incredible Web3 apps instead of constantly fighting merge conflicts. Be sure to visit forge.college to learn more about scaling Web3 projects. But I'll leave you with this final thought to ponder. If a new developer joined your repository today, how many hours, or even days, would it take before they could safely deploy to main without breaking anything? Keep building, and I'll see you in the next explainer.